Welcome back. This is part 2 of our Arduino project with the spooky skull, Scully. Yes, that's not right, I've named him. Spent a lot of time together. We've actually been out on the town. I've been using him in the carpool lane. That was good fun. Also, he did his job on Halloween night. We put him out in front of the house. We put some subwoofers around the front yard, and he really did scare the kids. In fact, there was this one cute little girl that was dressed up as a lamb. I think she maybe have been 4 or 5, and it was her first Halloween out and possibly her last. And you know, she cried. It was good times. Yeah. So Scully's done a lot of great work. I want to explain a little bit about how Scully works. Instead of using an Arduino project and then actually pushing the C code onto the board, we inverted it by putting Fermata on the board, which is a communications protocol. It's a C program. We loaded it onto the Arduino board. And then via that, we talk to the Proxy. There's a Proxy layer in between the Arduino board and the actual Flex project. And then in Flex, we talk via the Fermata protocol through the Proxy to the board to actually make it do its thing and make Scully nice and spooky. So let's get to the code and show you how it was done. All right, let's show you how to put together the Scully project and do the Arduino programming. So what we're going to do is we're going to start out by going to the Arduino website, and we're going to go to Downloads, download the Arduino software. Now I'm running on a Mac Lion OS here, so your setup is going to vary based on the environment that you're in. But I'm going to go to Mac OS X, and I'm going to download that software. And for demo purposes, I've already downloaded this software to make it easy and to eliminate any possible issues. So I'm going to go to my downloads folder where the software just downloaded it to, and I'm looking at look for the Arduino 0022 DMG. That's going to change based on the version of the software that's been released. I'm going to open this up. I'm going to need to install 2 programs. I've got the Arduino software and the FTDI USB serial driver. So I'm going to drag the Arduino software into my applications folder. I've already done this, so I'm not actually going to go through that step right now. Also, the FTDI USB serial driver, you double click on this, fire it up, install the software. I'm actually not going to do this because I've already done this also. So now that we have the Arduino software installed, we're going to fire it up. We're going to Applications, Arduino. We're going to open it up. We're going to open up the sketchbook here. This is the main area where you do your work if you're coding in C and uploading the sketches into the Arduino software. But what we're going to do is we're instead going to use the Fermata software, or we're going to use a Fermata program that's going to be uploaded to the Arduino board that's going to allow us to communicate over the Fermata protocol with the board. So what we're going to do is we're going to go into File, Examples. We're going to go down to the Fermata section. This is all installed by default and downloaded by default. So we're going to go down here, and we're going to go down to the standard Fermata 2.2 for Uno. I have an Arduino Uno board here, so this is what I'm going to install. After you open it, you'll notice that the sketch comes up, and it's a C program. And if you want to go into it, it actually talks about, you know, it has the actual complete source code for the program to control the Arduino board over the Fermata protocol. We're going to go here, and we're going to click the Upload button. And you can tell that your software is uploading to the board because on the board in the middle, right in front of the USB port, is a TX and an RX light. Those lights will flash with transmit and receive when the board is receiving information. And another really important step is to pick your serial port that you're operating on first. So go to Serial Port. You're going to need to go up and look at the serial ports that are listed in your system. In my case, there's my device is connected to the USB modem FD3131. So I'm going to select that, and then I'm going to upload that program again. And then down here it tells me the status, done uploading. Great. So one thing we have to do here is just note that the serial port, this is DevCU USB modem FD3131. We're going to close the Arduino software, and we're going to go to the next step. So the next step is installing a piece of software called a proxy. The proxy is going to allow us to talk from HTTP to the serial port that the USB is connected to. We're going to do this with Tinker Proxy. There's a Sir Proxy and a Tinker Proxy. Sir Proxy is a little bit older. Tinker Proxy is based on Sir Proxy. I'm using Tinker Proxy for this. So I'm going to go to the Tinker Proxy website. I'm going to download the software. Of course, like all good demos, I already have that downloaded. So I'm going to go over to the Finder. I'm going to Downloads. I'm going to open up the Tinker Proxy zip. It's going to unzip that to a folder right here. I'm going to move this over to my desktop. And we're going to kill my existing terminal session. And I'm going to go to the desktop and delete the existing Tinker Proxy directory. And the reason I'm doing that is because it already existed from my last demo. So we're going to try this one more time. So we're going to take Tinker Proxy, which does not exist on my desktop now. And we're going to drag this over to my desktop. Great. So now my desktop's going to have a Tinker Proxy 2.0 directory. Now I'm going to go to the command terminal, because I like to work in the command terminal because it just makes me feel cool. And I'm going to go to my desktop directory. And I'm going to go into the Tinker Proxy directory. When you do a list in the Tinker Proxy directory, you'll notice 3 files: sirproxy.config, sirproxy.exe, and sirproxy.osx. Now, since I'm working in OSX Lion, I'm going to need to rename sirproxy.config. So I'm just going to do a move on sirproxy.config, and I'm going to rename it, base it to sirproxy.osx.cfg. You don't have to do this if you're using Windows. Sirproxy.exe will automatically find the sirproxy.config and you'll be good to go. But in Lion, you have to, the extension has to match. So we need to rename this to sirproxy.osx.config. So I'm going to go in here and edit this file. Now what I'm going to need to do is tell sirproxy, or Tinker Proxy actually, I'm going to need to remember, this is where the memory part comes in handy. I'm going to need to set this particular line. There's a lot of lines in here talking about your net ports and your COM ports and your baud rate and your parity bits. Most of this is fine for our application. None of these settings really need to be tweaked at this moment. But we do need to change where the serial device is looking. So we're going to change this to cu.usb modem FD3131. And then we're going to write it out. And now we're going to run sirproxy.osx. All right, now this says that the sirproxy is running and now it's waiting for clients. That's great. So let's do a little testing. One great resource that I like for testing the Fermata protocol is if you go to the Fermata webpage, not only does it have a lot of great information about the Fermata protocol and some design examples, proposals, and a lot of examples, but it also has this great Fermata test program. Go down here and download the correct Fermata test program for your platform. In my case, this is OSXX. So I've already done this, so I'm going to go to my downloads directory. I'm going to open the Fermata test image here. And I'm going to take the application and I'm going to drag and drop it to my desktop. So now the Fermata test program is running, or is available on my desktop. I'm going to double click it and open it up. It's going to bring up the Fermata test application window. And it's going to again ask me to choose a serial port. So this is where I have to remember the serial port that I'm on. Dev CU USB modem FD3131. So I'm going to select that. And it's going to bring up this handy dandy program. Now what you'll see here is the pins and the analog and digital pins that are available on the Arduino board. What we can do now is we can actually look and interact with the board and just play with it and see if we're actually connected and the protocol is installed correctly. So as you look down here, the analog pins are actually reporting off of the light sensor. So as I put my hand over his nose, as you remember, there's a light sensor in his nose, the value goes up. And when I pull my hand off, the value goes down. Off, on, or on, off, on, off. So the values go up and down. So we know that the light sensor is working. We also have LEDs installed in his eye sockets. So if we look at his eye sockets here, and we change pin 7 to a high, we'll notice that the light goes on in his eye. Pin 6, if we pull that to high, the other light goes on. Pin 9 is our servo, so if we go in and select servo, and we go into the program here and we move it back and forth, we'll see that his head moves back and forth. So now we've verified that everything's interacting correctly and the Fermata protocol is correctly installed on the Arduino board. We're good to go. So now we need to go to the next step, which is interfacing this with Flex. To do that, I'm using a library called AS3 Glue. This just makes communication between the Flex program and the Fermata protocol that's running on the board very simple. So we're going to go to the site here for AS3 Glue. We're going to go to the downloads, and on the left you'll see that the Arduino AS3 Glue bundle version 2.0 is the one that you'd like to install. So I click that, downloads it to my desktop. Again, I already have this on my desktop, so I'm just going to go into the Finder, go to my downloads folder. Here it is right here, Arduino AS3 Glue bundle version 2.0. I'm going to click on this, expand it, open that directory, and you'll notice that it comes with a few things. The source file, it also comes with its own version of Proxy if you'd like to use that proxy, and it also has a monitor program. Now the monitor program is the same, pretty much the same monitor program that the Fermata tester uses, but in this case it runs in the Flash environment. There's an executable and a Flash version of it. So let's run this real quick. I like to run this because it not only tests the Fermata protocol, but it also tests the proxy connection with the board. So as this program's running, it's running in Flash, and it's showing us the same pin arrangements and input and output as the Fermata tester did. On the right-hand side here, you'll see a nice graph that they put in. And this graph is actually graphing the values from the light sensor. So as I put my hand over his nose, you'll see the values go up and back down, up and back down. Also down here, you can notice that the values go up and down the same way. So we know that we're wired in and we're receiving analog data from the light sensor. Over here, we also have pins that we can play with here. It shows that pin 6 is a digital input pin. I can take that pin Oh, I can't take that pin. I was confusing that with the other program. Sorry. I can go over here and set pin 9 as servo, and then actually play with the servo. Again, just like I did in the Fermata Test program. All right. It's great. This is all connected. Light sensor's working. Everything's connected up. Flash is communicating. This Flash program is communicating with our Tinker proxy, which is communicating with the Fermata protocol that's running on this board. So now I'm going to close that up. Let's create our own program. So I'm going to go into Flash Builder 4.5. I'm going to open it up. And as it slowly opens up, all right, there we go. Cool. So now we have a fresh IDE here. We're going to go in and we're going to right click and say New Flex Project. We're going to name the project Shell. I'm going to put it in my code folder under the Arduino directory and call it Shell. It's going to be a desktop application. It's going to run air, and we're going to use the Flex 4.5 SDK. I'm going to hit Finish. Now we have a standard shell application here. There's nothing special, nothing in it at this moment. So now what we need is to include the libraries necessary to talk with the proxy to the Arduino board. So we're going to do that by installing the AS3 Glue source code. So under source, there's a com directory and a net directory. The com directory actually has the monitor program. And it's great. It's a great thing to look at. It has a lot of nice example code in here. It has the actual monitor program that got ran up here. And you can check out the way they did the pin monitoring and the monitoring and the graphs and the wave plots. It's really good sample code. But really, to run our program, all we need is the net directory. So we're going to copy and paste that. And then we're going to go over to where our code is. We're going to go in the shell directory. We're going to go in the source directory. So this is where our Flex project is at currently. And here's the MXML that I was working on. I'm going to copy and paste the net directory in there. Okay. So now I'm going to go back over here, and I'm going to notice that now in my Flex project, I have the namespaces that I want to be able to connect with the Arduino board. There's the Arduino.as object and the Arduino with servo object. Great. So we're ready to go. So let's wire this up. So first thing I'm going to start off with is by creating some global variables. So I'm going to cheat a little bit. I have a lot of this over here in my boilerplate cheat sheet. Somewhere. Okay, here it is. Okay, so I'm going to put in two things here real quick. One is my imports. These will be imported automatically as you actually start coding. It will type and complete and import these items for you. But I'm going to talk through this real quick. I'm importing the Arduino object, the Arduino with servo object, the Arduino event, and the Arduino sys execution event. Now, if you look in my globals, I have an Arduino with servo object, and I've named it A. Save some typing. Anyways, the Arduino with servo, there's two Arduino objects that you can work with. The one is just the regular Arduino, and that's good for your digital input and output. And then the other one is Arduino with servo, which is what we're using for this project because I have a servo under his head, if you remember correctly. So now the other globals are for the pin light sensor, the pin servo, the pin left LED, and the pin right LED. These will line up the numbers. So pin 0 on the actual Arduino board is the light sensor. Pin 9 on the header here on the Arduino board is set up to be the servo. Pin 7, again, wired into the LED. Pin 6 wired into the other LED. Putting them up as global variables is the only way to go because you can't go searching through the code looking for pin 9 everywhere and change it if you have to make a change. Plus, when you're looking at the code and you're saying set pin high and it says 9, you got to go look and follow the wires to figure out. You might forget what pin 9 was. By setting up global variables, it's really easy to understand what your intention was. All right, so now that we have those set up, we're going to create an application on an it. Event handler. Okay, so we're going to make, as soon as the application starts, the windowed application initializer fires, we're going to set up the Arduino object and set up a couple event listeners. So again, I'm going to go to my boilerplate code and copy and paste some of it in here. The first line, what it does is creates a new Arduino with servo object on the global A variable. If you look at this object, which is interesting, because it's a Tinker proxy, is an HTTP proxy, you're basically connecting to the local host port 5331. So in theory, you could be running this program across the network in another room, anywhere. You could have the Tinker proxy running on a box completely across the office and be able to communicate with it just over HTTP. I have a trace line after that. After that, I have an event listener on the Arduino object waiting for the connect event. This is going to wait for our socket connection. And then I have another event listener waiting for analog data. And then I have another event listener waiting for the firmware revision. So let's put in these event listeners and see how this works. The first event listener is going to be the socket event listener. Because once you've established the Arduino with servo object and you've bound it to this IP, it's going to try to make a socket connection. And when it does, we're going to have it go into this method, and it's going to output to debug socket connected. And then I'm going to use the Arduino object and issue a command method. I'm going to request a method called request firmware revision. Now there's two reasons for this. We want to get the firmware revision, one, to see what version's running on there, and two, to establish that we have, or maybe one, to establish that we have connection with the Arduino board, two, to understand what the firmware revision is on the board. So when we make this request here, it's going to come back with an on-receive firmware revision event handler. It's going to fall in here. We're going to look at the e.value. That's going to tell us what firmware revision is on the board. The AS3 glue works with the Fermata 2. So what this is doing is checking to make sure that the value is higher than 2 or equal to 2, just to make sure we have the right Fermata program running on this board. All right, so once it gets done with that, we're going to have it do a little routine, call a method called init Arduino. Again, I'm going to go to boilerplate and grab some of that and put it right in here. So what init's going to do is basically initialize some of the pins on the Arduino board. And again, another trace statement. I like to be verbose. First, we're going to do Arduino.setPinMode. And again, here's your global variable for the servo. Instead of having to remember that that's pin 9, I just type in pin servo, and I know what pin it is. So I'm going to set that pin to the Arduino with servo constant. This is a constant that represents, I believe, the value 3, and it's going to pass it in there and set that pin up to be able to communicate with the servo. Now we're going to turn on analog reporting for a pin. So we're going to do Arduino.setAnalogPin reporting, and we're going to pass in, again, another global variable for the light sensor. And then we're going to set this to the constant Arduino.on. And then down here, we're just going to do another trace that outputs the value of the analog data on light pin sensor. So basically, it's going to trace and say analog pin 0 is, and then Arduino.get analog data for the pin light sensor. That's just a quick read on the light sensor. It's not really necessary. All right, so we're missing one more event handler that I initialized up here on the window initialize, which is the on-receive analog data. Because down here on this line, I told it we want to get analog reporting on a pin, we're going to need to listen for those analog reporting events. So here's the on-receive analog data event handler, and it's going to get an object of Arduino event. And all we're going to do with the value that comes out of that is we're going to trace to the debug the pin value that comes back. So e.value is the value that's going to come back from that pin. And the pin that we're listening for, if you remember correctly up here when we set up the event listener, or when we set the analog pin reporting, is the pin light sensor. So if I go back up to my variables, that is analog pin 0. So let's fire this up and make sure it works. So we have Tinker Proxy running. Here's our program. So let's fire it up. So now it should be establishing a socket connection with Tinker Proxy and talking to the Arduino board. If you look in the debug console, we're now getting a value from the light sensor on the nose of the Scully hair. Now, as I put my hand over it, it's going to go higher. Pull my hand off, it goes lower. Higher, lower, higher, lower. Very compelling. All right, so that's all it's doing right now. That's cool. We've gotten some data. Great. Let's have a little fun with it now. So what I'm going to do is I'm going to go into design mode. We'll throw in a couple buttons. One for Scully's left eye, one for Scully's right eye, and we'll label these accordingly. So right eye, label this one, left eye, and then we'll generate event handlers for both. There's the event handler for the left eye. So what we're going to do is when this event handler, when the button click event handler goes off, we're going to call Arduino dot right digital pin. We're going to do pin left LED, comma. Whoops. I want to get rid of that tooltip there. Okay. Arduino dot high. So we're going to put that pin in high mode. All right, and then let's see, we need another event handler. So we're going to go back to design mode. We're going to click on the left eye. We're going to click on generate event handler, and it's going to generate another event handler for us. And this is the right eye, I believe. So we're going to do Arduino dot right digital pin right LED dot Arduino high. Now, by pulling the pins high, we're going to turn the LEDs on. To turn the LEDs off, we need to pull the pins low. We're not going to do the off at this point, but we're going to do we're just going to turn his eyes on. So we're going to run this program yet again. Okay, and we're seeing that we're getting value. So we have values coming in from the light sensor. I'm going to turn his head to face the camera because what we're going to do is look at it, and we're going to turn on. Can we even see it? Oh, I can't turn his head that way. I want to hurt the servo. So let's put in a servo control so we can turn his head in that direction. So what we're going to do is go back into design mode. Go down and grab the horizontal slider. And we're going to make it really big because I'm getting old and it's hard to see now. So we're going to do a minimum. This servo has a range of 0 to 180 degrees. So we're going to set the minimum on this to 0 and the maximum output value to 180. We're going to set the step size to 2. So each time you move it, it's going to give you 2. And then what we're going to do is generate an event handler for it. And in this event handler, what we're going to do is we're going to write the value of the horizontal slider. We're going to write that to the analog pin there. So Arduino.write analog pin. And then we need to know the pin. So pin servo. And then we're going to have to send a whole number, so we want to round it. And we're going to do this. Actually, I don't believe the horizontal slider has an ID. Let's put an ID on the horizontal slider so we can reference it. Each slider servo. There we go. So now it has an ID so we can reference it. So we're going to go this dot each slider servo dot value. Oop. Lazy code completion there. Look at that. All right. So value. All right. So now what's going to happen is when this event handler or change event handler fires, it's going to take the value and write it to the servo pin. So let's try this again and move Scully's head. And then we can see the LEDs light up. So now we have the program running. And I'm waiting to see that the pin value is running here. So we can see now that we have interactivity with the light sensor. So that's great. So now let's try the servo. Okay. Looks like his head's moving. So we'll move it back towards the camera. If you want to get a shot of this, we're moving the servo back and forth on the H slider here, and his head's moving. And now we can turn on the right eye, which would be my right, his left, and then the left eye, and we can toggle those on. And we have control of his head. So this wasn't the complete project on how we did the Scully scare the neighbors, scare the bejesus out of the neighborhood kids when they're trying to trick-or-treat project. But we've set up a simple shell here that allows you to now start being able to work on your own projects and interact with your Arduino board via Flex to bring to life your own creative ideas. So I hope you enjoyed my Arduino session. I know I did. I had a great deal of fun playing with the Arduino board and interfacing with Flex and learning new ways to scare kids in my neighborhood. Always good times to get paid to play with new technology and scare kids in your neighborhood. Be sure to check back on our blog for new interesting videos that we'll be coming up with about new products and technologies here at Adobe. Also check the Adobe TV for great videos about Adobe products and things that we're doing on our team.